welcome back to this class. Till now, we have covered content given in the Unit 1 of your digital electronics course. That is the sign number. There are three ways through which we can express negative binary number. That is sign magnitude, one's complement method, and two's complement method of representing negative binary number. Then canonical representation, midterm and max term. And after that, we come to know how we can simplify a given Boolean expression by reducing its minimum, expressing Boolean expression in minimum number of literals. So we use this kind of map simplification method up to 4 variable. We have not gone to 6 variable. Then later on, we have also covered this twin multiplexity minimization method that is popularly known as tabulation method. Then R and R minus 1's complement method for subtraction. This subtraction operation like A minus B that can be done with the help of A plus B or B complement. So with the help of this R and R minus 1's complement, we can do subtraction operation with the help of addition process. Then BCD codes by decoded decimal number and gray code and its conversion. So now today we shall move to combinational logic circuit. Unit 2. In combinational logic circuit, by definition, combinational logic circuit is a circuit in which output depends on the present input condition. It doesn't have any memory element. It doesn't have any flip-flop. So combinational circuit is a circuit in which the output of a logic depends on whatever present inputs are given. So example of those logic circuits are adders. In adder we have different kinds of adder like half adder, full adder. The example carry adder, loop ahead carry adder, subtractor. In that subtractor we have half and full subtractor, parity circuits, decoders, encoders, multiplexer, demultiplexer, and the applications. We will study this one also. And lastly, code converters. So today we will begin this unit 2. So let us see our book. This was Nano. And we have to go to chapter 4. Yeah, I hope this screen is visible. So chapter 4 of Morris Minor is about combinational logic circuit. So by definition, as you know, this is a block diagram of combinational circuit. In this we have m outputs and we have n number of inputs. So output is a function of input. So this is as simple by definition. So if we have n input variables, suppose four number of inputs are there. So how many combinations are possible? 2 to power n is 16 different combinations are possible. So, okay, in this first section tells about the analysis procedure. Analysis means you have a given circuit, you have to analyze what this circuit is doing by breaking into different subsections. So that is the meaning of analysis. And what is the procedure of analyzing a given circuit? It is mentioned here. Suppose a circuit is given, you will see as an example also. So first of all, we have to do labeling of all gates output that are function of input variables with arbitrary symbol, but with meaningful names. Determine the Boolean function for each gate output. Label the gates that are function of input variable and previously labeled gates with other arbitrary symbol. Find the Boolean expression for these gates. It's the second level. The third, repeat the process outline in step 2 until the output of the circuits are obtained. This final output. And last is by repeated substitution of previously defined function, obtain the output Boolean function in terms of the input Boolean function. So let us see a given example. So you can see this is the in figure 4.2. This is a combination logic circuit. And in this circuit we have two outputs, F1 and F2. Two outputs are there. So we have to find out what is Boolean expression of this F1 and F2. This is the ultimate goal. And what is the procedure? We have to label these intermediates outputs of each gate. So we give here inputs like A, B, C, then A, B, C, A, B, B, C, B, C. This may be given. If not given, then we have to give from our side. Then we can write a output in symbolic form, that is say T2, T1, this is T1, this is T2, and this is T3, and since this is F, this is F output, and F output becomes the input of this NOT gate, so obviously this shall be F2 dash or F2 bar, and this is T3, which becomes the input of this OR gate having output F1. So this is the labeling. After that we have to write the functions. And how can we write function? Let us see, it is given here. Yeah. First one is this F2. F2, let us see here. F2 is here, F2. And what is the expression of F2? Let us see. F2 is equal to, you can see F2 is output of this OR gate, means summation of three things. This is number 1, number 2, and number 3. So this is AB plus AC plus BC. So this is the straightforward F2. Okay, and complement of this will be available here. Okay, suppose this is here now, and here we can write T1. T1 is equal to A plus B plus C, and T2 is equal to A, B, C. And after that, here you can see T3. We can write T3 like this F2 bar, this one. Then, so this is AND A, and so we have to multiply. This is A plus B plus C. This is now T3. T3. And F1 is nothing but summation of T3 plus T2. And T2 is A, B, C. So this is how you can write the expression of F2, T1, T2, and T3 is function of F2 bar, T1. And now finally F1 is T3 plus T2. And now we have to write all expressions by doing algebraic manipulation. As you have seen this, this is F2 bar. Here we multiply by this A plus B plus C plus A, B, C. And you do algebraic manipulation, and finally you will get this expression. F1 is equal to A bar, B, C bar plus A bar, B bar, C plus A, B bar, C bar plus A, B, C. So this is the function. And after that, we can write the truth table. Since in this diagram, you can see three variables are there. So A, B, C. So your F1 is a function of A, B, C. F2 is also a function of A, B, C. And we got now F2, expression of F2 as well as expression of F1. Now based on that, we can write the truth table. So 4.1, gives the truth table. So A, B, C, so add is equal to 3. So 2 to power 3 means 8. So there are total 8 possible combinations like here. So I will write, no, I will write number was 1, 2, 3, 4, 5, 6, 7, 8. So total 8 combinations are there. So with the help of 3 variable input, we can write all combinations like 0, 0, 0, 0, 0, 1, 0, 1, 0, up to 1, 1, 1. Number wise, it will go decimal number right from 0 to 7. Now we have to write the expressions F2. So F2 we can see here, we have already got this F2 is AB plus AC plus BC. This is F2. So here F2 is written. So AB, you have to do multiplication. Is AB 0 multiplied by 0, this will be 0 plus AC plus BC. Here we can write AB plus AC plus BC. So AB 0 multiplied by 0 will be 0. Then AC 0 multiplied by 0 will be again 0 plus BC 0 multiplied by 0 will be 0. So 0 plus 0 plus 0 will be 0. So that is why the output is here 0. Same thing you have to apply for each one. So here F2 is AB plus AC plus BC. And complement of F2 will be here. Wherever we have 0, we will put 1, and wherever we have 1, we will put 0. So that is the complement. 1, 0, 1, 0, 1, 0. Next is finding the F1. So F1 is a function of T1, T2, T3. And what is T1? T1 is here. T1 is A plus B plus C. So you can see here, this is T1. Let me give it a T1 is A plus B plus C. This anyone, if what, you will get output 1. So here you can see if all are 0, so output is 0. Whereas any inputs 1, this output 1. So you can see this is 1, this is 1, here 1, here 1, here 1, here 1. With all other combinations, there is at least one input is 1. So that is why you will get the output 1. So T1. T2 is multiplication is A, B, C. Let us see, is it okay? Yeah, T2 is A, B, C. It means unless all inputs are 1, you will get 0. So to get output 1, you have to take 1, 1, 1 as input. AD 0, this will make output 0. So you can see T2 only for this combination, and like 1, 1, 1, you will get 1, otherwise all are 0. Then T3 is function of, you can see here, T3 is a function of F2 bar, is complement of F2 and T1. So this is multiplication it means. So it will give output when both are input 1. So this is T3. Here, see this F2 and F2 complement and T1. So inputs are T1 and F2 complement. So in this, T3 will be 1 when both inputs are 1, 1, and this and this. So that we have 1. So for this case, one is 0 and another one is 1, that is why it is 0. Here again 1 and no other cases there where T3, T1 and F2 bar is 1, 1. So this is how we can write T3. And after that F1 as final expression. F1 is T3 plus T2. So T3 plus T2. AB 1, these two will give you output 1. So this is how we can write the truth table. So an important way of finding the expressions or analyzing. So this topic was how to analyze a given Boolean circuit, or say a combination circuit basically. So these are the steps. So this is unit section 4.3, analysis procedure, and with the help of example we have analyzed. So same question may be asked in example, or say exercise. Some of the circuits are given, you have to find out the expressions of output. Then design procedure. Design procedure is just reverse of analysis. Here, statement of the problem with specification must be given. We have to determine the inputs. So in analysis, we have a given circuit. You have to tell what circuit is doing. In design procedure, you already know what circuit is doing or what circuit is supposed to do. You have to design this circuit. So design of combinational circuits start from the specification of the design objectives and culminates in logic circuit diagram or a set of Boolean functions from which the logic diagram can be obtained. So let us see, this is code converter. Okay. So here question will be design a VCD to access3 code converter. This is a simple question. Design a VCD to access3 code converter. So this is the statement of the problem. So this designer has to know what is this BCD number, what is the input, and what is the relationship between input and output. Input is BCD and output is access3 code. So BCD number basically is 4-bit, as you know, binary coded decimal. So it starts from 0000 to 1001. That is the 9, from 0 to 9. BCD number goes from 0 to 9. The way we have decimal. That is why its name is binary. Number is expression binary, coded decimal. Basically, this is a decimal number, but coded into binary form. Okay, so now this is the input. So for this particular combination of the input, what is the corresponding output of access3 code? So access3 code is nothing but just addition of 3. So 0 plus 3 will be 3. 1 plus 3 will be 4. So you can see here 0, 0, 1, 1 is 3. This is 4. This is 5. But in SS3, this is called say 0, 1, 2, 3, 4. You cannot tell. I'm just trying to correlate with your binary number so that you should not look that you are not familiar. So SS3 number start from 3 instead of 0. So nevertheless, let us find out. Now when input is 0, 0, 0, 0, output is 0, 0, 1, 1. When it is 0, 0, 0, 1, that is the 1, then it will be 4. If it is 2, then it will be 5. If it is 3, then it will be 6. If it will be 9, then it will be 12. But in access3 code, it is 9 only. Okay, only we write like that. So that is why it is a code, not a number. Okay. Once we have written a truth table which express the relationship between input and output. So you can see this is the output and this is the input. So after that, next step is to find out the expressions of each variable like z, y, x, w, so that we can realize the circuit. So for that, we have to use our Karnaugh map. So in Karnaugh map for z. So this first one is simplification for z. So that is the z is the least one here in access3 code. So this is the z. We have to put these information in the Karnaugh map. Okay, and for rest, because Karnaugh map has 16, for 4 variable has 16 locations. So up to 9, it's okay. 0 to 9, you will have this specific output. But after that, it is not defined. There you will put don't care condition. So you can see here. So F0 is 0, that uh, that F1 will be 0. You can see here. This is 1, then 0, then 1, 0, 1, 0, 1, 0, 1, 0. So let us see it like that. So 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, and up to 9 you have this output. But 10, 11, 12, 13, 14, 15 all are don't care because it is not defined. That is why we put this X symbol which expresses that this is a don't care. Similarly, we fill up the information for Y, X, and W. So that is why you can see we have four outputs Y, X, and W. Now let us see how to solve it. Solution, we have to go for the maximum number of ones, adjacent ones. So you can see here this is 1, 1, cross, cross, 1, 1, cross, cross. So we can make easily octet. So like this. Okay. So from this you can see bar, D bar is common. So that is why output is D bar. It's last one. D bar, D bar. C, here this is C bar, this is C. So that is why it is not common. And here all are cancelling. So solution is this one for as far as Z is concerned. Similarly for Y, we fill up information and find the solution. So this is becoming quad is group of 4 adjacent one, another quad group of 4 adjacent one. So from here we can see the solution is CD. This one CD and here C bar D bar. In fact, this can be further reduced as C exclusive dot D. This can be simply implemented with the help of this logic gate. Now next, what is the X? You fill up the information, simplify for X. Fill up the information for W, simplify Boolean expression. So you get here, not say Z is equal to D bar, Y is equal to CD plus, this is another way of writing the C bar D bar using D order with X and then W. And after that, realize the circuit. Here you can see Z is nothing but D bar. So this is D and D bar is being Z, Y, X and W. With the help of different logic gates, we can realize the BCD2 SS3 code. So this is how we can do design of circuit. So steps are simple. We have to know what are the relationship between input and output. So in that cell, we can see this is the procedure. Please remember, from the specification of the circuit, determine the required number of inputs and output and assign a symbol to each. Second is derive the truth table that defines the required relationship between inputs and output. And third is obtain the simplified Boolean expressions for each output as a function of the input variables. Draw the logic diagram and verify the correctness of the design manually or by simulation. So today we have learned how to analyze the circuit and how to design the circuit. That is the combination logic circuit. Now this was definition and here analysis procedure. We see the steps, 4 steps, and this is the design procedure. Just inverse of that. Here we have given statement of the problem, then based on that we have to design the circuit. So with this, thank you so much. Soon we will meet again. If you have any query, please let me know. Thank you for being here.